COVID-19 is an infectious disease caused by a new coronavirus introduced to humans for the first time. It is spread from person to person, mainly through the droplets produced when an infected person speaks, coughs, or sneezes. These droplets can land in the mouths or noses of people who are nearby. These droplets are too heavy to travel far in the air. They only travel approximately 1 meter and quickly settle on surfaces. This is the reason person-to-person spread is happening mainly between close contacts. The exact time that the virus can survive on surfaces is not yet known. So it is wise to clean surfaces regularly, particularly in the vicinity of people infected with COVID-19. Hands touch many surfaces, which can be contaminated with the virus. You should therefore avoid touching your eyes, nose, or mouth, since contaminated hands can transfer the virus from the surface to yourself. When coughing or sneezing, cover your mouth and nose with the bend of your elbow or use a disposable tissue. If a tissue is used, discard it immediately into a closed bin. The most effective way to prevent the spread of the new coronavirus is to clean your hands frequently with an alcohol-based hand rub or soap and water. This will eliminate the virus if it is on your hands. Stay healthy and prevent the spread of COVID-19.
VIII students, today we are going to start the next chapter, Visualizing Solid Shapes. So before going to the chapter, we can see some introduction on 2D and 3D shapes.
2D and 3D shapes. Children, you have learnt about plane and solid shapes in class 2. Let us now revise and consolidate our knowledge. Plane shapes are those that can be drawn on the flat surface such as paper. It has two measurements, length and breadth. So it is also known as two-dimensional or a 2D shape. Square. A square has 4 sides. All the sides of a square are equal. A square has 4 vertices. Rectangle. A rectangle has 4 sides. The opposite sides of a rectangle are equal. It has 4 vertices. Triangle. A triangle has 3 sides. It has 3 vertices or corners. Circle. A circle has no vertex. It is a closed loop. It can be traced with a 1 rupee coin, carom coins, etc. Children, now let us know about some solid shapes. Solid shapes have 3 measurements: length, breadth, and height. So a solid shape is also known as 3-dimensional or 3D shapes. Solids have faces, edges, and vertices. Some of the shapes of solids are: look at the shapes of objects shown here. All these objects have the shape of a cuboid. A cuboid has 12 edges. The point where 3 edges meet is called a vertex. A cuboid has 8 vertices. A cuboid has 6 faces. In the given figure, 3 faces are visible and 3 are hidden. count the faces of your book. It has 6 faces. 1 front face, 1 back face, 1 top face, 1 bottom face, and 2 side faces. Look at the shapes of objects shown here. All these objects have the shape of a cube. The die with which you play is a cube. A cube has 8 vertices, 12 edges, and 6 faces. Children, we have seen all the objects shown here in our daily life. All these objects have the shape of a cylinder. A cylinder has no vertices. It has 2 curved edges and 3 faces. One face of a cylinder is a curved face. 2 faces, that is the top and bottom of a cylinder, are flat. Children, now take a look at the shapes of the objects shown here. Each one of these objects has the shape of a sphere. A sphere has 1 curved face. It has no vertex and no edge. Children, now look at these familiar objects. All these objects have the shape of a cone. A cone has 1 vertex and it has 1 curved edge. It has 2 faces, 1 curved face and 1 flat face. All solid figures have 3 different views: top view, front view and side.
Let us learn more about solid shapes, their characteristics, their different properties, and what are the different views of the solid shapes.
We come across many objects in our daily lives that have length, breadth, and height or depth. Take a look at the Earth, for instance. It resembles a sphere. While packing for a trip, have you ever noticed the shape of a suitcase or a trunk? That too has 3 dimensions. Similarly, the pyramids of Egypt, a waffle cone, a lawn roller, a football, to name a few, are all examples of 3-dimensional solid shapes. Welcome to the lesson on Introduction to Solid Shapes. At the end of this lesson, you will be able to count the number of faces, edges, and vertices of solid shapes. You will also be able to identify the nets of different solid shapes and draw isometric and oblique sketches of solid shapes. Look at this sheet of wrapping paper. Can we say it has length, breadth and height? Not really. Paper has only length and breadth, and hence is classified as a plane or 2-dimensional figure. All 2-dimensional figures have only length and breadth. Now, take a look at this biscuit tin. Can we say it has length, breadth and height? Yes, it does. 3-dimensional solid shapes have length, breadth and height. Many solids that we see in our day-to-day life have 3 distinct parts, namely faces, edges and vertices. Take a look at the 3-dimensional solids given here. The flat surfaces that form the skin of the solids are called its faces. The line segments that form the skeleton of the solids are called edges. In other words, two faces meet at a line segment called the edge. Finally, vertices are the points where three edges meet. Now, look at the square pyramid given here. How many faces, edges and vertices do you think the pyramid has? We can see that it has 5 faces, 8 edges and 5 vertices. Similarly, we can count the faces, edges and vertices of other three-dimensional figures. Did you notice that the three-dimensional pyramid is actually made of two-dimensional faces? The pyramid here has 4 triangular faces and a square base, which are all two-dimensional figures. Let us now discuss another way of visualizing a solid object. A three-dimensional shape can be visualized in a two-dimensional form by creating nets. The net of a three-dimensional solid is the two-dimensional skeleton outline, which when folded results in the three-dimensional shape.
Oh. Oh.
Look at this colorful cube. It's three-dimensional as it occupies space. Now we will observe this cube from three different directions. We will look at the top view, the front view, and the right view. Let's get started. How would this cube look if you were viewing it from the top? All we would see is the top face, which is a square. The top view of this cube is a square. Okay, let's come back to the original position. How would the cube look if we view it from the front? We would see just the front face, which is also a square. The front view is also a square. And how would it look if we view it from this side? A square again. Whether we look at it from the top view or the front view or the right view of the cube, we will always see a square. So this involves a bit of imagination, and we should try this out with different figures. Here's another figure. An empty glass. Take a moment and think about how the top view would look. Yes, all we would see is a circle. This is the top view. And if the top wasn't covered, we would see the circle of the base as well. And what about the front view? Pause the video and give it a thought. This is what we would see. A trapezium. Two sides parallel and two non-parallel. And the view from the right? Again, it would be a trapezium. No matter which side you look at it from, we will always see a trapezium. So imagining the views was pretty easy here. How about we make it a bit more exciting? I will be placing a few colored cubes on this plane surface to form a figure. Okay, so here it goes. I placed two red cubes here, one yellow cube on top, and one blue cube here. This is the solid we will be referring to for this example. We have two red cubes, one yellow cube, and a blue one. Now we need to draw the top view, the view from the front, and the view from the right. How would the top view look? Pause the video and try to draw it in your notebook. Let's try drawing it without moving the figure. If we look at it from the top, we will have the yellow square at the bottom. We draw a yellow square here. And this red cube will not be seen from the top as the yellow one is covering it. Next to the yellow square, we have the top face of the red cube. So we draw the red square face here. And to the right of the top face of the red cube, we have the top face of the blue cube. So we draw a blue square here. This will be the top view. If we take the camera on top, we can see that our figure is correct. Now let's get back to the original view. Looking at this, I want you to try drawing the view from the front and the view from the right. Okay, let's draw the front view first. The front view is the view from here. At the bottom, we have the front face of this red cube. So we draw a red square here. Imagine you are standing here. Now from the front view, what will we see on the top of the red cube? It will be the front face of the yellow cube. So we draw a yellow square on top of the red one. And at the bottom, next to the front face of the red cube, we will see the front face of the blue cube. We draw a blue square here, and that completes our front view. Let's rotate the figure to verify our answer. Yes, we are right. And what about the view from the right? In the same way, when we view the figure from the right, we will get a red, yellow, and blue face like this. How will the view from the right look? This is the view from the right. Notice that the front view and the right view look the same. Drawing views from different angles simply requires a little bit of imagination, and with enough practice, you will surely excel at it.
Hello students, today we are going to talk about how to look at the top view, front view and the side view of a three-dimensional object. Suppose we have 5 cubes here. So each cube has 6 squares or 6 faces. So let's say we arrange these cubes into a three-dimensional object in this way. So let's just assume that this is the front view. This direction is looking the object from the front, and we can call this the front view. And the other direction, looking from the side, this side, we call this the side view. So this is the side view, looking at this direction, side. And finally, we have another angle called the top view. That means we are looking at the object from the top. So it will be looking from this direction. So this is the top view. And now we are going to check what is the shape of the three-dimensional object from the front view first. So we move the camera in this way. So this is the front view. That means we can only see 4 squares here. So these are the 4 squares. And what about the side view? The side view is looking from this direction. 3 squares. 1, 2, 3 squares. And finally, the top view. So if you look at the object from the top, we can only see 1, 2, 3, 4 squares. So note that the top view is also aligned with the front view. The top view, the front view, and this is the side view.
Perspective of 3D shapes. Let us learn about the 3D view, that is, front, side, and top view of a cube and cuboid. This is a Rubik's cube. This cube has length, breadth, and height. It has 3 dimensions. It can be viewed from the front, side, and top. The red colored face shows the front view, which is a square. Now, come back to the original position of the cube. The green colored face shows the side view. If we observe the side view, standing in front of it, it is also a square. Again, come back to the original position of the cube. Similarly, the yellow colored face is a top view or the plan. Observe the yellow colored face from the top. It is also a square. As all its faces are squares, it is understood that a cube is formed by joining squares. Now, let us look at the 3D view of a cuboid. Here, the pink face is its front view. The blue face is its top view also called as the plan. And the yellow face is its side view. Kids, we just saw how the three-dimensional shapes look when drawn on a paper which is two-dimensional. This art of representing three-dimensional objects on a two-dimensional surface to give the right impression of their height, width, depth and position in relation to each other is called perspective.
Visualizing solid shapes. Solid shapes are the three-dimensional shapes. We have already learnt about these shapes: cube, cuboid, sphere, cylinder, cone, pyramid, prism and hemisphere. We can classify the solid shapes into two types: shapes with curved surfaces such as cylinder, cone and sphere, and shapes with flat surfaces. Solid shapes which are entirely made up of flat surfaces are called as polyhedron. The plural of polyhedron is called as polyhedra. Polyhedra are described by the number of faces, edges and vertices they have. 1. Faces. The polygonal region of any solid is called its face. 2. Line segments common to intersecting faces of a polyhedron are known as its edges. 3. Vertices. Points of intersection of edges of a polyhedron are known as its vertices. Regular polyhedron. A polyhedron is said to be regular if its faces are made up of regular polygons and the same number of faces meet at each vertex. Irregular polyhedron. An irregular polyhedron is made of polygons whose sides and angles are not of equal measure. Let us see some regular polygons one by one. A regular tetrahedron consists of 4 faces. Each face is an equilateral triangle. It has 6 edges, 4 vertices, and at each vertex 3 edges meet. A regular hexahedron consists of 6 faces. Each face has 4 edges and is a square. It has 12 edges, 8 vertices, and at each vertex 3 edges meet. A cube is also called a hexahedron because it is a polyhedron with 6 faces. A regular octahedron consists of 4 triangles meet at each vertex, 8 faces, 6 vertices, and 12 edges. A regular dodecahedron consists of 3 pentagons meet at each vertex, 12 faces, 20 vertices, and 30 edges. A regular icosahedron consists of 5 triangles meet at each vertex, 20 faces, 12 vertices, and 30 edges.
Combination of different shapes. Lighthouse surmounted by a hemisphere. Cone surmounted by a hemisphere. The above shapes are a combination of different shapes. We use these shapes in our day-to-day life. Views of 3D shapes. We live in a three-dimensional world. Every object you can see or touch has 3 dimensions that can be measured by length, width and height. Example 1. The room you are sitting can be described by 3 dimensions. The monitor you are looking at has 3 dimensions. Different views of a dice. Side view, top view, front view. Different views of a car. Side view, top view, front view. Mapping space around us. Usually maps are used to locate a particular place, river, mountain, etc. Map is different from picture. This map is drawn by Radha. In this map, the route from her house to her uncle's house is shown. How far Radha's house from her uncle's house? From this map, it is very difficult to find which place is near from Radha's house. We do not know the distance between circles. So, there is lack of information. We cannot answer to the questions. This map is drawn by Ravi. Ravi uses different symbols for different landmarks. Longer line segments have been drawn for longer distances, and shorter line segments have been drawn for shorter distances. He has drawn the map with a scale. Symbols and mentioning distances has helped us to read the map easily. The actual distance is denoted by 1 centimeter or 1 mm in the map. This means that if one draws map, he/she has to decide that 1 centimeter space in that map shown certain distance, say 1 kilometer or 10 kilometer. This scale will vary from map to map and not within the map. Faces, edges, and vertices. Faces. The polygonal region of any solid is called its faces. Edges. The line segments along which two faces intersect. Vertices. The points at which 3 or more faces meet. Polyhedron. A three-dimensional shape whose faces are polygon is known as polyhedron. It is derived from Greek word poly means many, hedron means face. So polyhedron is a three-dimensional object with many faces. Example: the faces of cube are squares. The faces of rectangular prism are rectangles. Polyhedrons: triangular prism, cuboid, octahedron. Non-polyhedrons: those solids which have curved surfaces are not polyhedrons. Cylinder, cone, sphere. Convex polyhedrons: if the line segment joining any 2 points on the surface includes faces, vertices and edges of the polyhedron, lies on the surface and does not intersect itself, is called a convex polyhedron. Convex polyhedra. We know that a polygon is called a non-convex polygon if the line segment joining any 2 vertices does not lie on the polygon. Similarly, we can define polyhedron. Given below are few examples for non-convex polyhedron. Non-convex polyhedra: small stellated dodecahedron, great stellated dodecahedron, great isosahedron, great dodecahedron. Regular convex polyhedron: the solids which are convex and whose faces, edges and angles are congruent are called regular convex polygons. Examples of solids which are regular convex polyhedron are tetrahedron, cube, octahedron, dodecahedron and isosahedron. Regular octahedron: an octagon with 8 equilateral triangles as faces. Prism. A prism is a special type of polyhedron. It has 2 ends which is of same shape and size. These ends are parallel to each other and are separated by rectangles. A prism is named according to the base of the prism. For example, the bases of the prism ABCDE and ABCDE are equal polygons which are parallel to each other. The faces are the rectangles AABB, BBCC, CCDD, DDEE and EEAA. AA, BB, CC, etc. are called lateral edges. Prisms are classified according to their bases. Triangular prism. Triangular prism is composed of 2 triangular bases and 3 rectangular sides. Pentagonal prism. If the base of the prism is pentagon, then the prism is called pentagonal prism. A prism is called a right prism if the lateral edges are perpendicular to the bases. If they are not, it is called oblique prism. Pyramid. A solid shape with triangular side faces meeting at a common vertex and having polygonal base is called a pyramid. Some pyramids have square bases. Example, Egyptian pyramid. They are called as square pyramid. A triangular pyramid is also known as tetrahedron. Pyramids are classified based on the base of the pyramid. Triangular pyramid, tetrahedron. If the base of the pyramid is triangular in shape, they are called tetrahedron. Square pyramid. If the base of the pyramid is a square, then they are called square pyramid. Hexagonal pyramid. A pyramid has a hexagon as its base.
What is a pyramid? The only pyramids probably everyone remembers are the ones in Egypt. But that's not the only type of pyramid. Let's erase this and draw the pyramids ourselves. It looks something like this. Notice that it has 1, 2, 3 and 4 vertices. Let us name them A, B, C and D. It has just one base, and this base is a triangle. It's triangle BCD. It has 3 faces and all of them are triangles. The 3 triangles are ABC, ACD and ABD, which is at the back. This is called a triangular pyramid. It's called that because its base is a triangle. Here's another figure. It has one base, which is a square, and this figure had 4 faces, all of which are triangles. It has one triangle placed on each side. This is called a square pyramid since the base is a square. So how do we define a pyramid? A pyramid is a shape which has one base and all other faces are triangles. And the type of pyramid is derived from its base. Triangular base, triangular pyramid. And square base, square pyramid. And remember, all other faces have to be triangles. Video, we tried to understand one of the most interesting three-dimensional shapes. It's called a prism. Most people think of a prism as something like this, but have no idea about its correct definition. So let's erase this and start with the definition of a prism. It's a three-dimensional shape that has identical parallel ends and all flat faces. Well, it's the most confusing definition ever. Identical, parallel, flat, there are just too many things. So forget the definition for now. Let's just look at figures and understand prisms. Look at this three-dimensional figure. The most important thing in topic of three-dimensional shapes is visualizing the shapes. Few of the lines are dotted because those are the lines that cannot be seen from this view. Look at the ends of this figure. It's a long figure with 2 ends. Now let me color the 2 ends for you. This figure has 2 triangles at its ends. And it has 3 rectangles as faces. This one in the front, one at the back, and one at the bottom. Now we look at the definition. It says that the ends are identical and parallel. They are identical since both are triangles, and both the triangles are parallel to each other. The definition also says that all its faces should be flat. And in this figure, all faces are flat. They are rectangles. This, by the way, is called a triangular prism. Here's another three-dimensional shape. Let me color its ends. We can see that it has two rectangles as ends and they are also parallel to each other. And it has four rectangles as faces. One on the right hand side, one on the left hand side, one at the top and one at the bottom. So all its faces are flat. This is called a rectangular prism. So if you noticed, the prisms are defined by its ends. Triangles as its ends, triangular prism. Rectangles at its ends, rectangular prism. Look at the rectangular prism. Does this shape remind you of another three-dimensional shape? Yes, a rectangular prism is also a cuboid. Now let's look at a few figures and understand if they are prisms or not. Remember the definition: identical parallel ends and all flat surfaces. Here's the first figure. It's a part of a pipe. Both the ends are circles and are parallel to each other. It means that this figure has identical parallel ends. This figure has identical parallel ends but has a curved surface. Hence, it's not a prism. I want to emphasize there are only two things that make a three-dimensional shape a prism: identical and parallel ends, and all its faces flat. Here, the ends are flat, but the surface is curved, so it's not a prism. Here's another figure. First, we look at the ends. Both are triangles, and hence we can say that this figure has identical ends. But wait, they are not parallel. The upper triangle is slightly tilted. So this figure as well is not a prism. Now assume we have a plane with a rectangle on it. If we project the rectangle upwards, equally from all sides, we get a prism. In this figure, we have projected all the sides to the same height. But what if we do not project all the sides to equal heights? If we do not project it equally, like in this figure, we do not get a prism. This is not a prism as its ends are not parallel. Is there a relationship between the faces, vertices, and edges of a straight-faced solid? Every straight-faced solid has faces, vertices, and edges. Take the example of a cube. This is how its three-dimensional view looks like. We need to find the number of faces, the number of vertices, and the number of edges in a cube. Let's count the number of faces first. It has 6 faces in all: top and bottom, front and back, left and right. We write a 6 here. How many vertices does it have? 4 at the top and 4 at the bottom. 8 in all. And how many edges? Pause the video and write the number of edges here. Let's count. 4 horizontal ones at the top, 4 vertical ones in the middle, and 4 horizontal ones at the bottom. 12 edges in total. Now here's the important question. Is there a relation between these 3 parameters of a straight-faced solid? The answer is yes. For any straight-faced solid, if we add its number of faces to its number of vertices and then subtract the number of edges, we get one special number. And that number is 2. For a cube, 6 plus 8 minus 12 gives us 2. And this holds true for any straight-faced solid. Which are the other straight-faced solids we know of? Cuboid is one. It looks like this. A cube is nothing but a special case of a cuboid where the length, breadth, and the height are equal. So a cuboid also has 6 faces, 8 vertices, and 12 edges. And F plus V minus E will give us 2. Let's see if it works for other straight-faced solids. Do you remember what a square pyramid looks like? It is a figure with a square as its base and triangles as its faces. Square base and 4 triangles as faces. And what is a triangular prism? A prism is a three-dimensional solid which has identical and parallel ends and all flat faces. A triangular prism would look like this. It has two identical and parallel triangles at its ends and three rectangular faces. What do we need to find out here? We need to find the number of faces, the number of vertices, and the number of edges in each of the solids and see if F plus V minus E will give us 2. Okay, let's tackle the first solid, a square pyramid. How many faces do you see? There are 4 triangular faces and 1 square face. 5 in all. How many vertices? 1 at the top and 4 at the base. 5 vertices. And how many edges? 4 slant edges and 4 edges at the base. A total of 8 edges. We got F, V and E as 5, 5 and 8 respectively. And 5 plus 5 minus 8 will give us 2. So it worked for the square pyramid too. F plus V minus E gave us 2. This is called Euler's formula. For any straight face solid, F plus V minus E will always give us 2. Will Euler's formula work for the triangular prism too? Why don't you give it a try? Okay, so how many faces? 2 triangular faces at the ends and 3 rectangular faces in between. 5 faces. How many vertices? 3 at this end and 3 at the other, 6 vertices. 3 edges at the front face, 3 in between and 3 at the back face. 9 edges in all. What will be 5 plus 6 minus 9? Yes, we get a 2. We will always get a 2. That's Euler's formula. F plus V minus E will always give us a 2.
Dear children, write all the necessary definitions and complete the notes according to your textbook. All the definitions and study all the required results and properties of solid shapes. Reference of textbook is very important. And also complete the homework from exercise 10.1 and 10.3. The questions from 10.1 you can complete in your textbook itself and do all the remaining problems from exercise 10.3. Hope all of you understood this chapter very well. So revise the chapter properly and complete the notes. Meet you in the next class. Thank you.